everyone for tuning in. As you already know, this is a cloud data-driven meetup user group. Our agenda for today is Azure SQL DB Hyperscale. The game has changed, right? You, give me a second. You are free to comment as long as you're doing it with respect. There must be no offensive comments. It would be great if every one of us could keep our video and microphone off. And then please type your questions. You are free to unmute your microphone unless if it's being asked. And then our presentation for 2 days, as you already know, is Azure SQL Hyperscale. I'm gonna have Armando introduce himself because he's one of the great speakers out there. He's a senior specialist. Not only that, he's an architect, right? Speaker, trainer, developer at heart. That's absolutely true. And then he's a Microsoft MVP. Not only he's certified, but he knows what he's doing and presenting as well. We have a couple feature presentation lined up, which is new feature in SQL Server 2019. I would highly suggest every one of us to come enjoy Javier. He's gonna introduce to you all the new features related to performance and also when it comes to administration as well. We have another one on February 4th that would be statistic. It's gonna be related to statistics, SQL Server statistic. You guys know Magnus, he's a great speaker as well, and SQL Server specialist, he's MVP, right? And then we have on February 10th, we have Grant that will talk about index selection. Please join these 3 sessions, right? And then also, if you guys want to present a session, feel free to do that. Email me at jjoseph@bigdatadriven.org. And then thank you for attending our webinar. Don't forget to follow us. Feel free to share this meetup group with your friends or peers. And this session is being recorded just for your information. And then now, Armando, I would love you to take over, share the screen, introduce yourself. And it is an honor to have you today with Armando. Thank you so much.
Well, the pleasure is just, it's all mine, John. Thank you very much to have me with your SQL group. Hello, everybody. Hello from sunny Northern California. I live here near Napa Valley. Great neighborhood, if you know what I mean. My name is Armando Lacerda. It's a pleasure to be here with you. I apologize for my technical issues. For some reason, my PowerPoint in my VM didn't want, is failing, is freezing up when trying to open the slide deck. So I'm presenting from the actual browser. So hopefully the presentation, the animations will work fine. We'll see. In any case, my name is Armando Lacerda, like it's written there, a couple of, and we are here for Azure SQL Database Hyperscale. I want to share with you some important information that I believe is valuable for people who are on-premise or even already working in the cloud and wants to investigate SQL DB Hyperscale offering in Azure. So a couple words about me. I'm a senior BI and Azure Architect. I work for Wintellect. You can see that on the slide deck frame. I'm gonna talk about Wintellect a little bit, but yeah, I work with Azure for over 20 years. You know how that happens, right? You usually start with a training. So I was in a conference, and this guy there presenting a particular session asked everybody to pop up their laptops, and the first one to deploy a web application in Azure back in 2010 would win a prize. I did not win the prize, but I did deploy my first web application, and my career with Azure just got started. Since then, been working on and off with Azure for about 4 years, and then for the past 6 years, pretty much all my projects were around Azure, with either hybrid or just purely in the clouds. And I've been helping many companies and many friends of mine to get their head in the cloud. I've been working with data for over 30 years. I started as a developer, and back in the 90s, I fell in love with data warehousing. Started working with mainframes, and then moved into Oracle. And then when SQL Server 7.0 came along, I fell in love with the thing. I was seduced by the dark side of the force, never looked back into Oracle that much, and I've been working with SQL Server since then. Actually, SQL Server 6.5 was the first one, but that was kind of more of a toy. 7.0 was a real platform for larger databases. I would love if you connect with me on LinkedIn. I like to make new friends, new connections on LinkedIn. And I don't tweet much. Usually it's about something interesting I find around, and I tweet about that particular news when I hear from Microsoft. I'm a Microsoft MVP on data platform. I'm also a Microsoft certified trainer. I've been training Microsoft content, been delivering Microsoft content for about 30 years too. And there are a couple of my certifications there. All right, so the company I work for, Wintellect, is a consulting company down in Atlanta, Georgia. It's a great place to work for, and is I'm part of a great team, you know, great professionals, and they make me better on the things that I do. We've got all these Microsoft certifications there. A lot of our colleagues, they are well-known authors of books that developers, Wintellect's much more into development and architecture, and we are getting stronger on the data platform. And for the development people, if you have done Windows development, you probably have read one of the books that were written by either my colleagues or former colleagues who got hired by Microsoft. Microsoft sometimes goes by and picks up some of our colleagues. Just one left last December to join Microsoft. There's this thing called Wintellect Now, which is training. Like I said, I do a lot of training. I don't have any content on the Wintellect Now, but it's online, your paced training, recorded videos. If you're interested, take a look, and you may want to screenshot this one here. Martha can give you 10% discount. So that's a little bit about me, the company I work for, and the projects I've been working with. Talking about projects I've been working with, I just stepped out from a project that was heavily on Hyperscale. So a lot of the things I'll be showing here is from my just recent experience on this particular project. The current project I'm at is not running Hyperscale, and I miss it. But yeah, so this is our agenda today: understanding the offerings we have in Azure, and we're gonna take a look on some specifics of Hyperscale and what will be next for you, right? Besides the questions. And talking about the questions, like John already mentioned, if you have questions, you may pop them up in the chat, and I'll ask John to let me know. I will have some time at the end for you to ask questions too. If you have questions in the middle of the presentations, you may jump in if you like. I don't have any problem with that. Yeah, if you can write in the chat window, it's also okay. All right, so I try to choose some humor here about the SQL Server offerings. And the thing with the SQL Server offerings is, in the past, or if you're still working on premise, I shouldn't say in the past, right? Because SQL Server is really strong on premise. I'm the one not working much on SQL Server on premise. But if you work with SQL Server on premise, SQL Server 2019, which is the version you deploy on premise, is the latest one. If you have to choose, you choose one of these options, right? I need to deploy SQL Server, so I just have to choose which edition of a particular version. So 2019 got these editions there. 2017 got pretty much the same lineup, the same editions. And the thing about these editions is the feature collection. So if you go Express, you really don't have a service, right? It's just the engine that's attached to an application you deploy. If you go web, you have a max amount of cores that the web engine can support. And if you look into the documentation, they will tell you that's designed for SQL Server running alongside with IIS on the same VM environment, kind of. Same thing for standard. Standard, you get more features or less features, and enterprise would be the full featured one. For that, I do have here some pages, some web pages for us. And this guy wants to chat. I would say no thanks. Yeah. So here's what I'm talking about, right? When you look into in between versions, you see some features that are available on a particular version, not available in another. And that's how you go by choosing which SQL Server you want to deploy, right? So if I want to deploy SQL Server, if I don't need big data clusters, for instance, I'm okay with deploying SQL Server 2017. But if I need big data clusters, which is a feature that is specifically for SQL Server on-premise, I go for SQL Server 2019. And within a particular version, you get the specifics of the editions, right? You get the Web Express, Standard, and Enterprise. And then you see some of the features and some of resource utilizations growing up. So web can get up to 16 cores, standard up to 24 cores, and enterprise unlimited, right? This is your mindset when you go and you try to select which SQL Server you want to deploy for a particular business case, for a particular environment. What you see happening in most companies out there is they usually put a server up and they support multiple applications on that particular server. So there will be multiple databases supporting multiple applications on a particular server or a collection of servers in a cluster, for instance. So it's very common for large corporations to deploy multiple enterprises and then start licensing those enterprise deployments by the amount of cores they have and therefore amount of memories and so amount of memory and so on. Here, on the same page there on this data sheet from Microsoft, you see the feature collection. Like I said, you go and why do I need to use enterprise? I can save money, put in a standard if this amount of cores supports the application I want to do, and if I don't need to use, for instance, this particular feature here, right? Automatic read and write connections, rerouting. So that's not available. This feature is not available on standard, but it is available on enterprise. So it could be a decision point there for me to choose either edition. Life was easy. That's how life feels like and still feels like. I have this tendency to say used to feel like because I'm not doing that much on-premise work anymore. But that's how it feels like for people who are still working on-premise. When you go to the cloud, a lot of these things, they just go away. Because when you go to the cloud, you have the options to deploy as a platform as a service offering instead of infrastructure as a service, which this one would still apply. So if I go back here to my slide deck, when I go into the cloud, and specifically when I go into platform as a service, and I don't want to dive into that, it's kind of off topic of the hyperscale, want to focus on the hyperscale. But when you go to Azure, you want to create a new SQL database. I left here the tab open for this. When you're going to create a SQL database, you have the option to go for a database, a managed instance VM, or your own VM managed by yourself, your own VM, right? So you have these three options there, and you can choose whatever you want. These two ones in here, the SQL database and the managed instance, are the ones that platform as a service. And hyperscale lives here, right, on the SQL database. This is where you're going to find hyperscale. And so for these two offerings, SQL database and managed instance, because they are platform as a service, and this is my cue to go back here, you don't have to worry about, for instance, disks. You have no control about this because you don't see disks. When you connect to those instances and you see your database in there, you don't see the server. There are no server options to manage. So we have no control over disks. When you create a database, you don't have to pick up drives or where you're going to place your files. And as a matter of fact, most of your server level settings, they are hidden from you because the server in a SQL database platform as a service is more likely into management of firewall connections and network connectivity, and have like your SA used to be the SA account for the databases on that server. There are some other things you can control from there, but nothing related to this. So all of those things about CPUs, about memories and all of that, they're not controlled the way they used to be on-premise, right? They are controlled by the service level you want to implement. And this goes into the resource limits. So before I got into the resource limits, let's go to a quick demo here and see a database creation. You may have seen this multiple times before, but I just want to highlight a few elements here for you. So let me get here resource group. I have probably this one here, should have a server there. Let's see if I can see a server. Huh. I may have deleted the whole thing. Let me go back in here. SQL demos. Do I have a server here? I don't have a server anywhere, so I have to create a new one. So when you create a new server, don't think about the server, as you probably know, don't think about the server like the SQL server you are deploying on premise, right? The server here is just to control access to the databases. Everything is focused on the database and not the server. The server is even free, it's not even charged, right? You're charged by the database. So I'm gonna go create a server here just quick. So SQL demo user group New Jersey. This name should be available. Nice. SQL admin and some password here. That should be okay. And because I am in California, I'm gonna use WestUS2 on the West Coast. So that should be okay. Yeah, don't worry much about this. This is not important. What's important is coming down. So this is gonna be my Hyperscale database demo. And this is where I want to point to, right? I'm going to stay away from this topic here about the Elastic Pool. If you have questions about that, you're free to email me if you like. Better than email me, you can send me questions on LinkedIn or on Stack Overflow. It's great because you're going to get my wisdom and the collective wisdom from the user members over there. So we're going to stay away from Elastic Pool for today's session. Here on the database configuration is where we will find our hyperscale right there. So when you get into here into these options, and just for the record, there was this previous ways of deploying SQL Server in the cloud based on DTU utilization. I used to teach people how this dark magic here, this witchcraft thing here is calculated, but now this is going into the history. We are not supposed to create new databases on this particular SKUs. Besides being not actually complicated, but unfamiliar to people, the new features and the new investments from Microsoft are coming on the vCore side of things, right? So don't come in here unless if you really need to create something that's based on these performance levels. So let's go back to vCore. And here's where you want to live. So if you can recall, right, from the SQL Server on-premise and 2019 elements, editions, or rather say, right, SQL Server 2019 editions, we have all of this standard enterprise and the web, and they're based on the amount of cores they use and the amount of memory they can support and some other features. So the features are not here, but this is your cores and your cores, and an interesting thing here is your database size. Because in platform as a service, there is a correlation for most of the offerings, but in hyperscale, that's why I named this session, the game has changed. Because before hyperscale, there was a correlation between the amount of vCores you have and the database size you can have. So like if I have 2 vCores, I can get my database up to 1 terabyte. My database cannot be larger than that. So if I need a database, if I don't have that much processing needs, which is kind of uncommon, but let's say you don't have much of that processing need, you hit this database once in a while, but you need to keep the data alive in the database and ready for querying when needed. And if your database is higher than 1 terabyte, you have to increase your amount of vCores so we can increase your database size. So like for 14 cores, I can have a database up to 3 terabytes. The max I can go in here is 4 terabytes. Let's see if I can get there already. Come on, keep sliding. Yeah, there we go. So after 2040, it seems I can get up to 4 terabytes of data, and this is the max you can go, and that is valid for both general purpose and business critical, right? If you go business critical, it's the same thing, you know, topped off to 1 terabyte. If you're starting 2 vCores, if you go all the way to 24, there we come here. Then I can go up to 4 terabytes. So you see these two options here, which are the most popular one. I mean, people will usually go for. They have this correlation between the amount of cores and the amount of memory, right? If amount of the database size, I rather say, if you need to store more data, keep more data in the database, you have to push your cores up. And like again, like I named this session, in hyperscale, this thing works differently, because in hyperscale there is a separation in between the compute side of it, which is the core allocation, and the storage side of it. They are detached from each other. They work together, of course, but they are detached from each other. So when I click here in hyperscale to select hyperscale, I can see that I have the vCores. There is a second slide in here, which is to be the database size, but this is not the database size. This is actually replicas, which we get in the replicas in a second. So I'm going to put this down here, just to put it down, and to show you that there is no database size. See, you got no database size here whatsoever. And the only thing you selecting here is the amount of vCores, because the database size is already controlled for you and increased dynamically as you push data in. So as you can see here in a calculator, you're paying for a particular amount of compute cost plus 10 cents per gigabyte per month. And in case you're not familiar with, this calculation per month is a month of 730 hours, which is a month of 30 days. So months of 31 days, you're going to pay a little more. And in February, you pay a little less, right? So this estimates here per month is always based on a month of 30 days. So you see how the game changed in here for hyperscale. My storage is not tied up to cores allocation anymore. So that's a very important difference in between hyperscale and the other ones. And there's also a difference in between those platform as a service compared to infrastructure as a service. On that note, on this feature comparison, we are talking about infrastructure from the infrastructure perspective at this point. So, okay, I got it. If I need more vCores, I go in here and I open up the vCores. And in terms of performance, performance speed and throttling, I can see up here, if you can see my mouse, I believe you can see my mouse, right? I can see up here that Microsoft publishes this performance targets. They're not really under SLA, so it's not guaranteed you're going to have this all the time, but you usually work within these boundaries in here. And as you can see, there's a kind of a fluctuation here, a midterm in between general purpose and business critical when you go into throughput. Now, this is the point where most people migrating to the cloud really tripped on. They really fall into this pitfall here, tripped on, because it's not so much published how the performance of this I/O subsystems work on each one of these offerings. Because when you go, like regardless if you're using enterprise, web, or standard on-premise, if you put your SSD, if you configure your I/O infrastructure, right, your connection to the storage, and then get your switches to your remote storage on-premise really well set up, you can get gigabyte throughput to your data files and your transaction logs, right, in your infrastructure. Like I mentioned before, for platform as a service, these things are throttled and they have a performance limit, and most people don't pay much attention to that. So I want to get you here so you can understand how that goes, how that works. And for that, this is one of the documentations you have from Microsoft about this. So here, see scale limits, and this one here, I'm looking specifically to SQL editions and components from premise, it seems. So this is the maximum performance levels you can get for SQL Server on-premise. But and again, you see vCores, you have a limitation on the edition you're using, and off it goes for everything else, right? The database size and everything else. This approach in this documentation that's on-premise changes radically when you go platform as a service. So this is SQL Server on platform as a service, right? The resource limits. And this is a pretty extensive, I think it's the best documentation we have about how these things work. And it goes for all offerings. So right now I'm looking at general purpose with serverless. And serverless is one fashion you can use, one flavor you can use for general purpose. But what I really want to show you here, and of course I'm going to let you dive into this after this session, is as you can see, you have limitations for TempDB. So if you work on premise and you're going to the cloud, you're like, when I deploy a server, I deploy my server instance, got the system databases. One of them is TempDB, and is one TempDB for all databases that are having that server. Now, when you go to platform as a service, that changes. You really don't have control over TempDB. You don't see TempDB whatsoever. I mean, you can query TempDB anytime. You can create temp tables, but you don't manage TempDB. That's what I mean. And as you work with TempDB, your particular database will have a performance limit on TempDB. So that idea that's one TempDB for all databases in my server, and however TempDB performance is shared among all databases, that is not valid to the cloud, and even more for hyperscale. So, for instance, in general purpose, right, with serverless feature, my TempDB size is related to the amount of vCores I use, right? This is the size of vCores. You see how many vCores I can have. So I'm going to jump from serverless, because serverless has this weird thing here, like you can have half of a core associated to your instance. I'm going to go down here to a more common one. Let's see here, Gen 5, Hyperscale. So let's look into Hyperscale. See, if you have one vCore, your TempDB is maxed to this size here. You cannot create objects that's a collection of objects in TempDB that goes above 32 gigabytes. And this is one of the things that, even though there is no relation in between the amount of cores you have and the amount of data you keep, like I can have one vCore and I can have 50 terabytes of data in Hyperscale. But when I want to process that data, then I may have to increase the amount of cores. For instance, if I have a table in my database, in my Hyperscale, and I need to create an index for that table, this is 100 terabytes. I'm going to go like there. This is transaction log. TempDB also increases in the same way. I'm not seeing here. I don't know what's not showing. But your throughput on to get to log, funny, it's not showing. Your throughput to get to log is 100 megabytes per second. It's the maximum one you can have when you are working. There you go, max log rate, found it. Yeah, I knew it's there. It's just too many numbers. So you see max log rate in there when you are working with the transaction logs is the highest one you can have. Even business critical doesn't get to it can get higher than this one if you go to the very higher end, but the majority of it is under 100 megabytes per second. When you are going into TempDB, right? So remember, when we're going to your Hyperscale, so that is applied for all the transactions you're going to Hyperscale. So pretty much what I'm trying to say here is when you're push data into SQL, because you're going to be charged by the compute and pretty much the compute they're being executed, you cannot have a better rate in terms of cost benefit when you are pushing data into SQL Server in the cloud. You cannot have a better one than using Hyperscale, because it's the fastest one you can have, and depending on how many multiple sessions you want, like if you're doing Databricks job that you're putting 20 parallel partitions into SQL Server, it's perfect for that. You're going to have the best ratio performance. Again, this is different from general purpose and is different from business critical, because general purpose is stopped on 32 megabytes per second, and business critical, it's going to vary amount depending on how many vCores you have. So all of these elements, they are very important. They are factors you have to compute, you have to take in order to make a decision on which service platform you're going to go for, right? Very important elements in there, and that's how it's so different, right? That's how the hyperscale is a very different game into SQL offering. One thing I need to call off in here is this one here, right? At this moment, when you create a hyperscale database, if you have to check mark this one here, because they want to make sure you understand that when you get data into hyperscale, you cannot get the data out to any other offering, right? Like if I create a database that is in general purpose and I do provisioned with whatever business tier in here, I can move from here to business critical and back here. I can move the data from compute to compute as as often as I want, as and schedule it the way that I want, because the data can flow over these SKUs. But if I do create a database in hyperscale, I will not be able to get out. So I can get into, like if I have a general purpose database, I can make it hyperscale, but I cannot make it back as of today. This probably may change in the future. It's been like that for a couple of years already. But as of now, you have to make sure understand you cannot move away. All right. Okay, so this is a lot of things in terms of features and performance that are different in hyperscale when compared to the other ones. To wrap up the session here, let me switch back to my presentation. To wrap up the session here, I would like to quickly dive into the architecture of the hyperscale, so you can understand how different it is, how specific it is when compared to the other ones. So what's the idea of a hyperscale? Storage is really detached, is disconnected from the computing element of hyperscale. General purpose and business critical, they work on environment and also managed instance that's really close to what you see on premise, where you see the data files associated to the compute associated to that data file. So they kind of blend together, if you may, or very close to each other, very coupled. In hyperscale, they're really disconnect from each other. It's designed for the cloud. It's not like a lift and shift from on-premise, if you may. But the idea here is the architecture is really taking consideration everything the cloud can offer. The compatibility is the same SQL. There is no much difference. There are feature differences though. Like at this moment, we cannot have in-memory tables yet, right? The hackathon tables, we cannot have those. Performance is, is one of the best performances you can have, especially when the bottleneck is I/O. It's comparable to business critical. Business critical is very stable. Hyperscale can catch up to business critical, but may fluctuate. And the limits in there, they say no limits. There is a limit. The database cannot be larger than 100 terabytes. Microsoft, if you look around on some Microsoft product group team presentations, they will tell you that they have tried with 200 terabytes, but that's not supported. It's not documented. Documentation is 100 terabytes. There we go, large database size, 100 terabytes. That's the very important thing, right? And the thing with the database size is you don't have to worry about the size itself, besides the bill. Because since you don't have to pre-allocate the size, you're not committing to the size, the database keeps growing automatically as you push data in. The catch on that one is if I push let's say 20 terabytes of data in, if down the road I delete or truncate a bunch of tables and then reduce from 20 terabytes to, let's say, 15 terabytes, the database size doesn't shrink. I will be keeping paying for 20 terabytes forever, unless if I drop the database and bring back up again with the new, in a new instance. So it increases, but it doesn't shrink. So we have to be careful about that. So again, like I mentioned before, data size and cores are built independently, and they can grow up and down independently. And there is no size of data operations. You can really push. You see, that's the other thing. On the log, on the transaction log, when you look at the transaction log for general purpose and business critical, there is a limit of the transaction log size. Your transactions cannot overrun the transaction log size. There is a limit there, and you can refer back to that page later to take a look on the transaction log size as it grows, as you add more CPUs or vCores. On hyperscale, you don't have that because of the disconnect, the decoupling of the storage and the compute. The transaction log flows on itself on pretty much unlimited. I'm sorry, on an unlimited amount of storage. So your transactions can really run as long as large as big data volume you may need. Of course, you're going to have performance issues if you have to roll back, if you're locking in table for too long and things like that. You're going to have race conditions, concurrency, and all of that. But the point is, you don't have a limit on your transaction, on the size, on the data size of your transactions, which is pretty cool in hyperscale. Where's my mouse? Let's keep moving here. So this demo here is a pre-recorded demo that Microsoft made available. It shows, it pretty much shows, I'm not gonna play this, kind of 2 minutes long, but the point of this one here is because of the architecture, which I'll be investigating a little bit with you scrapping right after this slide here, because of the decoupling of the storage, when you want to restore your database, it really doesn't take much effort to get the database online, not to finish the restore, but to get the database online. And this particular video here shows that a 50 terabyte database is being restored in here. They're restoring a 50 terabytes database, and at some point it will end. Let's see, there we go. So database was created, right, restored, and this is a 50 terabytes database and was restored in 7 minutes. Now, did you hear me well? 50 terabytes database restored to a second SQL Server instance in almost 8 minutes, right? So if in some very good deployments on premise, when everything is well tuned, you can get it like this. But usually, especially if you're reading from backup tapes and things like that, you're not gonna have a 50 terabytes database done in that sort of short of a time. So how is that possible? Well, let me get in here to this animation here. There we go. How is that possible? This is the core of hyperscale. How the structure is really different. Again, on a regular SQL deployment, you have a SQL server, the VM, and the SQL Server processor are running there, and you have your databases into that VM. So the VM holds the SQL Server and all the databases in there. On the hyperscale, you scratch that. Everything's going to be different. So you have 4 main blocks or 4 main domains in here. There is a compute portion of it that's facing your client applications, and is the one that's replying to your select. So when you go to Management Studio or Azure Data Studio and you do a select statement, they hit the compute that's associated here. This is the vCores you are paying for. It's right here in the compute. And this one here will talk to the storage managers, the page servers and the log service. These 2 guys here are the ones talking with the store. And each one of them, they have a local mirror or local cache to store within themselves. But the actual persistent store of your data is kept down here on the storage accounts, right? It's the regular storage accounts, like the ones we create in Azure. When you go create a storage account, you don't see this, you have no management over them. It's always done behind the scenes for you. This is platform as a service, so don't have to worry about that. This is just for you to understand how it works. So on a first glance, what happens is when a query comes in, let's say it's insert, update, or delete, it's hitting the log service, and the log service caches that. That's the one that gives you 100 megabits per second all the time. So it captures that and will send over time to the page servers to be refreshed on the page servers, right? That information on the dirty pages can be registered for those page servers and will be persisted at some point into the Azure store. And when you query data, that red arrow in there, when you query data first time, if the data has not been, that particular table was not being queried before, SQL Server Hyperscale will go into the storage, the cold storage, remote storage, populate or seed the page servers. So that first hit will probably take about 10 milliseconds to get answered for the data to get into the compute. When you hit that same table again, that same collection of pages that you have read before, and they're already metered into the page servers, then you get performance that's about 1 to 2 milliseconds. I have measured that, and I'm not the only one doing the benchmarks on this one here. There are other people doing this better than I do, and that's been the case. That's being measured and proven true. So again, let's do another pass here so you can make sure you grab how these things work all together. Let's say you are using Hyperscale Generation 2 with 2 vCores. So we have one compute element in there. And notice that it's a particular process there to take care, there are backs there that takes care of the log service. So when you do operations in there for changing, it talks to the log service in there. These options here you have in Hyperscale that you have something similar to this on Business Critical, but this one here is super cool. And if I go back here to this guy, and yeah, see the replicas down here. So if I want to, I can go ahead and slide this up to replicas, which means that I'll be creating more compute elements associated to this database for read-only operations. So here in the slide deck, oops, here on the slide presentation, was here somewhere. There we go. So this is what they're talking about. One is a read-write, and you can have up to other 4, or I think 4, up to 4 more, where you can have read-only elements. They'll be talking only to the page servers. They don't talk to the log, right? So it's always one read and write master and a lot of reads. So if you have done availability groups on premises, it feels a lot like those availability groups. So this one here, they cost less than this one. You do have extra cost involved to it, but they cost less to this one. So it's not times 2, times 3. It's a fraction of 1%. 100% is a fraction of 100%. And when your applications connect on the connection string, if they say, I want just to read, I'm like Power BI, I'm like Tableau, I'm like a report service. I'm not only going to read, I'm not going to write. They can be offloaded in here. And that makes a huge difference because while they are reading, they are not creating locks on a read and write replica. So writing operations here, they will not compete with locks. There will be no contention in between writing and reading. So that's a huge benefit of using Hyperscale right there, especially if you're doing BI like I do, like I myself, I do all the time. So that's that. So when data is changed, they go into this log service one that keeps the operation super fast and updates the pages and sends them over to the page servers. Of course, when there is a select going on, the replicas, they will go into the page servers to get those 30 reads pages. And each one of these page servers here, they are actually servers. So you see how much compute is spread around. You have compute over here facing the end users, and you have some compute over here that's pretty much doing caching of the cold storage. And I don't know if you can read that, it's kind of small, but each one of these guys, depending on your amount of cores you have in here, each one of these guys here have 1 terabyte data file cache, right? Ultra fast SSD cache to support these ones. That's how the performance is kept, right? In around 1 millisecond. So this whole thing is very specific to Hyperscale. That's why I named this session again. The game is really, 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 really different, right? You don't see that in the other offerings. All right, so Yeah, and on the data storage, file snapshots are always kept in there to support backup and restore if in case you need to roll back. Yeah, so that's pretty much about it. This is just to wrap up some of the major points on this one here. So read IO is super fast because it's done over the page servers. And when they mirror the code storage, you can get about 2 milliseconds for all data access. On general purpose, you have 0.5 milliseconds on business critical. On hyperscale, you can get to 0.5 millisecond as well as the same way you have in business critical if the pages have been already cached in the page servers. Otherwise, you're going to see some fluctuation, 2 milliseconds. It can get up to 10 milliseconds there. So you see it's a nice in-between, right, for a better price and more scalable storage. Wrapping it up, this is for business general purpose. So these are the summary of the elements there on the web page. You can take a look in there. Most of workloads can work well in here, unless if you have those specific elements, feature requirements we have discussed. For business critical, the very interesting thing about business critical, and trying to avoid, high availability and some other elements on that. There are some drawbacks on hyperscales in terms of high availability. It's guaranteed within the region, I think, but not in between regions yet. So that's one of the elements that if you need that particular feature, hyperscale is not your option for that one. And here is the summary for hyperscale, right? It's the best for VLDB workloads because it's the only one you can get more than 4 terabytes in there. So to me, it's pretty easy, right, to go for this one. If it's more than 4 terabytes, it's hyperscale, off we go. And this one here also summarizes that's a nice in-between option in between general purpose and business critical, right, to keep things simple. So with that in mind, what are the questions we have? John, do you have anything in the chat window?
No, I'm not seeing any question. Hey guys, if you want to ask any question, you are free to unmute yourself and talk to Armando.
I'm going to take the time to sip my smoothie here. Kind of quiet. I think I put everybody to sleep.
No, you have done an amazing work, Armando. You may not realize that, right? You
hello, really, I think I hear a question.
Okay, hello. I have a question. So if I want to do backup and bring copy to another place like local, how would I do this with hyperscale?
Right, you can't, right? So the regular backup, you cannot. Actually, you cannot do that with any of the offerings, but the virtual machine. So and there is a way also to do with managed instance. But for pretty much all the passes but managed instance, you cannot restore a cloud database into on-premise. So what you do, you export it like in a backpack format. You export it and then you import it into SQL, but you cannot restore a cloud database into an on-premise database. And the same way too, right? You cannot restore an on-premise database into a cloud database.
So would Backpack work for 4 terabyte?
Well, it would, right? You're gonna have problems with that, but you can create extraction options using BCP and things like that. The files are gonna be big, but you can have a backpack or that pack to create your schema and then report your data after. But the point is you have to export your data and then re-import into your target destination.
So no replication options, nothing like that?
No.
Okay, thank you.
Sure. Good question. Actually, that was an excellent question. Good questions are the questions I don't know the answer, I have to look for. And excellent questions are the ones I know the answer. So that was an excellent question.
Absolutely. Are there any more questions? feel free to mute yourself.
Yeah. All right. I really recommend you guys to take a look on those links I have shown you, and kind of try to dive into the specifics and try it out. Hyperscale.
Hi, sorry. Yeah. Will you be sharing the links and video, recorded video?
Yes.
Yes.
Fine.
And I can show the slide deck too if you like.
Yes, you can send the slide deck to me and I will post it.
Sounds good. I'll do that.
What about using Stretch?
Stretch.
Between on-prem and...
Carry on, sorry.
Can you use Stretch to move data from on-prem to Hyperscale?
No, Stretch databases, they used to be backed by Azure SQL Data Warehouse in the back end. After Microsoft released Synapse last year, there is a particular offering that's still based on SQL Synapse pool, but it's specific for the Stretch database, and that is an offer that's not Hyperscale. So to your question, you cannot stretch a database to Hyperscale. It stretches to the Stretch database services, which is a sort of a clone of Synapse SQL pool.
Okay.
Excellent question.
Great, yes. Thank you, Dan.
I do have a session on the Stretch database. I present that one on DPS last year. It's a feature. I think it's the first time I got a question on Stretch database in a very long time. Besides that session, people are not that familiar with that one. So thanks for the question.
No worries. I tell you, the offerings are getting a little confusing. Every time you think you've got your arms wrapped around the names.
Yeah. It's like going to a Starbucks.
Right.
Yeah, because I'm going to the create resource, the marketplace, and now all you have is Azure SQL and SQL Database. Right?
Azure SQL and SQL Database. Let me see.
If you go to create resource and you search the marketplace for SQL, you have two options. Other than the IoT and stuff and Edge, there are two categories: Azure SQL and SQL Database. They've changed that since the last time I created a database.
There we go. Yeah. So what I usually recommend people to is to come into this page here. You know, portal.azure.com, #create, Microsoft Azure SQL. They have it really well organized in here. So these are the options: single Elastic or database server. If you want to do single instance, or if you want to do Elastic pool, manage an instance, just single instance, Elastic pool is on here. And if you want to go VM, these are the images that are available and up to date for the VMs.
VM. But if you go back to the marketplace screen and just search for SQL.
Here.
Yeah. Now they have, there's Azure SQL, and where you were was SQL Database. And the descriptions, I mean, I'm sitting here trying to wrap my head around the descriptions. It's almost like SQL Database was the previous offering, but Azure SQL is where...
At least where I was.
Okay. Man.
Yeah, I really like this interface here. This interface really puts in perspective. This is a PaaS, regular PaaS. This is also platform as a service. It kind of compares with RDH, I think, from Amazon. And when you need to do like CLR, it's a feature that's not supported in any option in here. But if you need to do CLR store procedures and things like that, you're gonna find those in here, and a lot more server level configurations if you need to tweak those. And this is your regular VM. So this kind of simplifies a little. I like it. But last time I checked, there were over 60 SQL options in Azure.
It's getting crazy. All right, thank you.
Sure. Don't worry, you're not alone in the boat. It's crazy for everybody. All right. And again, I apologize for my technical issues at the beginning of the presentation. I hope that was beneficial to you guys. Jen, thank you again for having me in this session.
You are very welcome, Armando, and it's my pleasure. Thank you so much, Armando, and thank you to everyone for tuning in. Don't forget to join our next session, which we have a couple other sessions lined up. Give me a second. Let me share my screen with you. In case, please make sure you reserve your spot, right? One more time, thank you to everyone. Thank you, Armando.
Thank you.
Have a good one.
Have a great day, everybody.
Take care.